Can the speed of light be broken? Imagine that there is something that exceeds the speed of light, something faster than any known phenomenon in the universe. These particles, known as tachyons, are not only the subject of science fiction literature, but also serious discussions among physicists. Is it possible that certain principles which we have considered unbreakable, such as the speed of light, can actually be surpassed? Or maybe there are other forms of matter and energy that classical physics simply fails to detect. In today's episode, we will try to uncover the mystery of tachyon particles, so fast that they seem to break all the rules we know. Let's explore what lies behind this fascinating theory and how it could change our understanding of the universe. Speed of light, an unbreakable limit? The speed of light, approximately 300,000 kilometers per second, is one of the most fundamental limits in physics. It is said that nothing, neither matter nor information, can travel faster than light in a vacuum. Imagine that in just 1 second, light travels nearly 7.5 times around the Earth's circumference. This pace seems to be the absolute cosmic limit. But what if this limitation is not as unbreakable as we thought? According to Einstein's special theory of relativity, the faster something moves, the more energy is required to accelerate it. Achieving the speed of light for an object with mass would require an infinite amount of energy. That's why the speed of light appears to be a barrier that cannot be broken. But what if there are particles that start their journey at speeds greater than light? This is where tachyons come into play. What are tachyons? Tachyons are hypothetical particles that always travel faster than light. Let's imagine it differently. Tachyons are like marathon runners who are always in the lead. Their speed not only never drops below the speed of light, but actually increases as they lose energy. This phenomenon is somewhat the reverse of what we know from classical physics. In comparison, photons, particles of light, are like sprinters who always run at maximum speed but never exceed it. Tachyons, on the other hand, are sprinters who start the race beyond the finish line, always one step ahead. What's more, the faster they move, the less energy they require. Let's think about this. For ordinary particles, acceleration requires increasing amounts of energy, whereas tachyons work in reverse. They gain speed while losing energy. This sounds like a scene from a science fiction movie, but this theory has mathematical foundations in Einstein's special theory of relativity. Imagine that the mass of a tachyon particle has a negative value. This crucial element allows them to move at superluminal speeds. It's a bit like trying to slow down a speeding train that, instead of losing speed, accelerates even more. Why are tachyons so controversial? Although the mathematics supports the theory of tachyons, physics faces serious challenges here. The first problem is that tachyons could have negative energy. In the world of physics, something like this is almost impossible to accept, as it would lead to paradoxes. Imagine that tachyons have so little energy that they can travel back in time, moving in reverse. This would contradict our intuitive understanding of causality. The effect would appear before the cause. The second issue is the stability of such particles. Physicists point out that the field in which tachyons could exist would be unstable and could lead to violent phenomena, such as a tsunami of particles in the vacuum. In other words, instead of a harmonious universe, we would be dealing with chaotic waves of energy. How could tachyons revolutionize science? Despite these problems, tachyons have fascinating properties that could open up completely new perspectives for us. Some researchers suggest that tachyons could help solve one of the greatest mysteries of modern cosmology: dark matter. Dark matter is a substance that we cannot see, but makes up about 85% of the entire mass of the universe. It affects the motion of galaxies, galaxy clusters, and even the accelerated expansion of the universe. Let's imagine that tachyons might exist in vast quantities in space, interacting with galaxies through gravity, but remaining invisible to our instruments. This could explain why dark matter seems to be everywhere, yet impossible to observe directly. Furthermore, tachyons could also explain phenomena related to dark energy, responsible for the accelerated expansion of the universe. In one of the latest studies, scientists compared data from observations of Type Ia supernovae, which serve as cosmic markers of distance, and found that cosmological models with tachyons those with classical dark matter and energy. In other words, tachyons could be the key to understanding both dark matter and dark energy. Experiments and research on tachyons. Although the theory of tachyons seems fascinating, their existence remains hypothetical. However, scientists continue searching for evidence of their existence. One of the most interesting areas of research is the impact of tachyons on experiments related to the Casimir effect, a quantum phenomenon that occurs between two metal plates placed very close together in a vacuum. The Casimir effect is proof of the existence of so-called vacuum energy, the minimal energy present even in theoretically empty space. Scientists wonder if tachyons could interact with this energy in a way that could be observed in laboratory conditions. Although previous studies have not yielded conclusive results, future experiments may provide crucial information about the existence of tachyons. Cause, effect, and time travel. One of the most intriguing aspects of tachyons is the possibility of time travel. If tachyons move faster than light, they could theoretically travel backward in time. This leads us to a fascinating, yet terrifying, question. Could tachyons change the future by influencing the past? Imagine that in the future, you send a message to yourself in the past, warning of an impending danger. Would your actions in the past change the future that hasn't yet happened? This is the classic time travel paradox, which leads us to issues related to causality. Conclusion. Do tachyons really exist? Are they the key to solving the mysteries of the universe, such as dark matter and dark energy? Or are they merely a mathematical fantasy that will never be confirmed in reality? Scientists don't have the answers to these questions yet. But one thing is certain. If tachyons exist, they have the potential to change our understanding of reality in ways we can hardly imagine. Thank you for watching this episode. If you're fascinated by physics and want to learn more about the mysteries of the universe, subscribe to our channel and turn on notifications. Who knows? Maybe soon we'll discover something that will forever change the way we perceive our world. Let me know if you'd like this translated into Urdu or styled differently.